Alright, afternoon everybody. I'm going to try to keep this one short because this is annoying. I'm sure my neighbors are loving this right now. It's a real high pitch, but right now we have it in a partnered output configuration, no magnets, and pretty sure this is the slope that the guys, mostly Chris Stykes on Above Unity, that's what they call it now. It's actually bucking coils. Or opposing coils. There's a lot of information on it. It's not anything new. It's what Akula did, and I believe Chimpanzee did it. Don Smith definitely did it, and there's another one, I can't remember his name. Sparky Sweet, yeah, his diagram had partnered coils too. So right now these two are in series with one another. They're paralleled individually and then put in series. We are 2500 hertz right now. We could turn the other channel on. Oop, wrong thing. Oh, I was on 300 hertz. Let's change that. It probably didn't like that. Alright, now we're just didn't change it a little bit. But we just turned on the other MOSFET so that it's getting double the power, or potentially. It makes it easier. These are the MOSFETs that we got going. Pumping in 34 watts right now. It's 20% duty cycle on both. They're in phase, so they're just these two are just assisting each other. They're not flip-flopping or anything. There's my diodes, current sense, resistor, and the output of the POC is hooked to this, and this is just getting warm. It's not really warm, and I'm pulling voltage. The purple trace is the voltage off the heating element. The yellow is the current on the output coil that is that's doing work right now. And that's a let's see, move it a little better. Yeah, I mean, I could sweep the frequency. I'd have to turn one off a little bit. Because I can't do both frequencies at the same time on both channels. Let's turn it off. One off. Yeah, same thing. Power reduced a little bit, but not much. But yeah, that's the waveform they say to look for. You know, it took me a little while to get to this point. I had to make sure the diodes were in the right position. Diodes right there on the heat sink. I heat sinked these just so I'd make sure they'd stay cool for the measurement. There's a heat sink paste, ceramic or whatever it is I put on there. It's like a heat sink glue, and then there's a thermal Arctic 6 under everything. Arctic 6 under all this. So just wanted to show you this. The scope's about on its last leg. I think it is accurate, but I sent probably 1,000 volts into it in my early MEG test, so it struggles to turn on sometimes, but it passes all the tests. But yeah, that's a 240 volt heating element. So, you know, even when we're putting in, I doubt this is over Unity right now. I'd have to do a lot more tinkering with it and frequency sweeping. I did try putting a cap across it, and it didn't like it on the input. So I might experiment with that on the output a little bit. And these are pushing in the same direction. They're just assisting each other. Getting a little warm, not much, but yeah, this is the setup. These have fans, active cooling running right now. I don't know if you could hear that, but yeah, let's turn it off. Actually, what's the button? There we go. Froze it. So yeah, this is the regauge portion. This is supposed to be the work, and then regauge again, and that slope goes down. Is at 2500 hertz. The higher frequency did, and it's 20% duty, so the higher frequency did show it a lot cleaner. When I would ramp the frequency up, this would slowly shrink right here. So again, that's the current, and I wouldn't trust that gauge right here, this 20 amp. It might be impulses, I guess. I'm not doing average power math or anything. I think this can, but I'm not doing that right now. So yeah, this one is the bucking. It's in opposition with the diode. I drew the directions on there, probably backwards, but I just flipped them around until I got this, because only a certain config will get that. and this is the driving coil. So I don't know if y'all's interested. You can Google partnered out POC, partnered output coils, bucking coils. Asymmetric regauging is what some people also call this. So yeah. And I mean, I could check voltage in different places. That right there is the good opposition for it, because I am measuring current and voltage on that same coil. This one right here, the first one. So, all right, won't make it too long. Sorry for the piled up mess there, but I had to get all my stuff ready. Here's my induction meter. Works pretty good. Anyway, hope you all enjoy. Hope you all have a good day. I'm gonna experiment more with this a little bit. Just on the side, because I want to see what it's about. Probably should have more winds on there, and I haven't tried both in parallel to each other yet. I know it'll double the input probably, but alright, so I went ahead and doubled them up, so now they're in all parallel. 34 watts. Ironically, it's double the frequency, which is interesting. It's the same waveform though. So yeah, they're both, so that'd be 20 turns against 60 per each coil pair, which is times 3, which they say is a good starting point. Wished I'd went 80. I guess I still can, but anyway, let's freeze that. So yeah, it's not perfectly smooth, but even theirs I don't think was. Could probably clean this up a little bit. But yeah, the coil just lukewarm, but that can take a lot of current. I think it's like 14 or 15 ohms total on that coil. I wish I had a light, but I don't have a DC light right now, so I just throw that on there. Anyway, yeah, so there's both. Again, we were using the bottom channel, so that's at 5,000 hertz. Before we were at 25, so it's an interesting note. When I series those, make effective 40 turns, took half the frequency, so to get a similar shape. Anyway, peace.